Hello, welcome to LeetCode Solver. Today we are going to solve 25th problem in 30-day lead coding challenge, and the problem name is jump game. Given an array of non-negative integers, non-negative, you are initially positioned at the first index of the array. Each element in the array represents your maximum jump length at that position. Okay. Determine if you are able to reach the last index. Well, initially I will be at first index, which is 0th index. Okay, and and every index, the input itself represent maximum jump length at that position. From that position I can jump this much uh, amount further. I mean, if I jump from here, I can jump two times, maximum two times, so I can reach up to this index. From 2 I can reach up to this index. From this index I can either go to this index or either I can go to this index. Well, when I reach this index, I can either go to this index or I can either go to this index. I can either go to this index. Okay, and from this point I can only go to this point. And from this point I can only go to this point. And from this point I can jump 4 times, but it doesn't have any value. The value which is at the last index does not have uh, any meaning in this problem, because the problem is asking whether I'm able to reach the last index or not. If I able to reach last index, I don't have to jump further. So if it is 0, then it's fine as well. So I have to return true or false. Jump one step from 0 to 1. Okay, 0 to 1, and then 3 steps to reach the last index. Yeah, we can see from here, from this point we can jump to this point, and this point we can jump 3 steps further. Well, for this case it is false, because from this point we can jump up to 1 2 3 up to this position, and from this point we can jump to this position. From this point we can jump to this position, and we reach up to this position and we are blocked. Now we can't go any further because this is 0, jump length is 0, and the non-negative, so minimum it will be 0. Maximum it can be the length of the array, or it can be further more than that as well, doesn't matter. Well, what I'm thinking right now is, the problem looks straightforward to me. So as we are always going from left side of the array to the rightmost side of the array. So array position are number is 1 2 0 1 2 3 4 5, something like this. Then I have to see whether particular position is reachable or not. Like let's say there are some values over here, like 2 3 2 3 1 1 4, say 0, something like this. Example first. So I just need to keep track, like current value is current index is reachable or not while going from left to right. So when I'm here, I will be wondering whether this particular position, ith position, is reachable or not. And particular ith position will be reachable if some index before me, I mean all the index before ith index, which are say j index, which are less than I, from any index, if I can jump up to ith index, or more than that. So ith index is reachable or not. This is if any index j which is less than I can jump index more greater than or equal to I index. If this condition satisfies, then ith index is reachable. So if we go from left to right and for every I we check whether ith index is reachable or not. Then by doing this, then if we can reach up to n minus 1 position. So n is the length of the array. We assume that the length of the array is n. N is length of array, given array. So by doing this, if we can reach up to n minus 1 position, then we are done. Then we are reachable. Then we will return true. Well, now how we can find for every j, for every I, whether there exists j which can jump up to the position which is greater than or equals to I. So this is a simple way of calculation. Like for every j before I, we will be, while traversing, we will calculate, while traversing maintain, while traversing for every j, calculate where it can jump at most. For every j, we know where it can jump at most, which is like can be calculated by simply adding I with the given jump array, which is the maximum amount of jump length. So we add the jump length, which is jump length. Jump length can be found in index of I, so which gives us where it can jump at most, or maximum index it can jump to. This is this, and we will find maximum among all j less than I. Then this maximum value is this maximum value. If it is greater than I, then we are sure that we can jump up to I or more than that. So let's maintain this. Let's go for coding. So as we are iterating over the whole length of the array, the time complexity is definitely big O of n. Big O of n. We are, as we are iterating, and space is constant here because we will not be using any extra space. Well, let's go for the implementation. Let's calculate the length of the given array. Less than n. So we are iterating, and we will also be maintaining maximum jump. Maximum jump index. We can also say prefix maximum, because we will be dealing with all the I less than j. So say initially 0, and in every position we will check whether prefix max jump index from every prefix, for every prefix, if the maximum jump index, if it is greater than or equals to I, then we are fine. If it is less than I, then we will simply return false. Okay, in this case, ith index is not reachable, from any j less than I. Well, now we will be calculating the how much it can jump, and we will be relaxing this prefix max jump. Prefix max jump will be now equal to max jump index will be now equal to maximum of prefix max jump index so far and summation of current I with jump length provided to us. So whichever is the maximum, I mean from this point how far I can go, this value indicates that index, and this is the total prefix determined by all the prefix less than I, and we will find the maximum among all those, which will ultimately give us prefix max jump index for uh, for all the I just after this index. Well, now we can return true, because if at any point, like at the last point also, if we find this condition, if we reach out to this condition that prefix max jump index was less than I, then we will be returning false in that situation, otherwise we will be returning true. Let's see how it goes with the given sample. Well, initially we find the length. We may take this example as well, which has length equal to 1 2 3 4 5 5. So we calculate 5 for the first time, and then after index is 0, which means initially we can go up to 0th position as mentioned in the statement. So we can go maximum 0 index, and we will iterate over this, and we see that at 0 position the maximum 0 index is not less than I, so we will not returning false. Instead we will be calculating uh, the value which is maximum among previous value 0, and I plus num I, which is equal to 0 plus given at current position 2, which is 2. So from 0 index I can go maximum up to uh, 2 positions. So while finding the maximum among 0 and 2, I found it is 2 is the maximum. So we updated max jump index as a 2, and now we reach to 1 index. In 1 index we see that this is greater than I, so we will not be returning false, and we go here and we will be maximizing among 2 and 1 plus index plus jump of current position is 3, so 1 plus 3, which is 4. So now we will update this as a 4, because maximum 2 and 4 is 4, and we will reach up to 2 index. In 2 index we see that this is greater, so we will not be returning. Instead we will be calculating the current index, which is 2, and the maximum jump I can make from the 2 position is 1. So I will find out the maximum among 4 and 3, which is 4. So 4 is remains as it is, it will not be updated again, and we will reach up to, now we will reach up to third position. In third position we see that this is already greater, so we will not be returning false. Now we will update uh, third position 3 plus maximum jump length from third position, which is 1 again, so this is 4. So 4 and 4, maximum 4 and 4 is 4, and we will having this value again, and now we will go to fourth position, and in fourth position we see that the fourth position, this is also 4, so it is not less than, so instead it is equals, so we will not be returning false. Now we will calculate the maximum, although this is not for the last index, the calculation is not be useful though, but we will calculate. So what happens, 4 and this value is 4, and the maximum jump in it can make is 4, so it remains 8 at the final. But next time we will not be iterating because it reaches uh, up to limit of the index. So finally, as we are um, reaching in every index is reachable somehow, so we can return true as the answer, so jump is possible. Well, let's run the code to see if there is any compilation error or not. No compilation error. Let's try with custom test where we can put uh, say 0. It will give the same output as well. Mhm. But if we put something like 1, then it should give us false. Well, let's submit. Well, it is accepted. Let's see. Runtime is 12 millisecond and memory is 7.8 megabyte. Yes. So as I explained earlier, the time complexity is big O of n, as we are iterating over the whole array, where n is the length of the given array, and space complexity is constant because we are only using few variables, these two variables basically. And while calculating space complexity, we will not use the given space to us. We will just calculate the what is the extra space we are using while performing calculation and solving the problem. So yes, and thank you so much for watching these videos. And if you think that these videos are helping you, and you may subscribe the channel, and you may also comment if you have any other approaches to this problem. Yes, uh, thank you so much. Have a nice day.